Okay guys, I'm going to be going over all the questions on the practice final, which is almost identical to the final, just changing a couple of values and a couple of signs. Let's begin with question number 1 right here. Now of course your questions that you take on quizzes are going to be all mixed up, but on mine I have question number 1 right here, simplifying using PEMDAS. So we're going to begin with P parentheses, right? So when you go inside the parentheses you have the 2 plus 40, so that is 42. And let me rewrite the rest. Bring down the division, the 2, the minus, the 20. So after P, we have E exponents, and there is no E for exponents. But then after that, we have multiplication or division. Both the same color because they're both equal in value. You don't have to multiply first before dividing. You don't have to divide first before multiplying. It just depends what comes first from left to right. And you have your A and S, your addition and subtraction at the very end. So what are we faced with here? We already did parentheses. We now have division or subtraction. So obviously you're going to divide before subtracting. So let's divide. And we have 42 divided by 2. That is 21. 21 take away 20. The answer is 1. And that's why we have that answer right there, 1. Let's jump to question number 2. Question 2 says, which set of values is a function? Now the key to understanding this is that a function is like a machine. For each input, there's exactly one output. Again, what does that mean? It's kind of like you have a tortilla machine. You put in some dough, you get out a tortilla. You put in some dough again, you get out a tortilla again. That's a machine that works. That's like a function. But if you plug in some dough and you get out a tortilla, then you plug in some dough again and you get out a donut, that's the machine's broken. It's no longer a tortilla machine. You don't know what you're going to get out, right? So for each input, there's exactly one output. And we also need to remember that the inputs are the x values, that are the domain values. So on coordinates, we have x's and y's. So on this first option, this is an input, and the input 6 gave us the output 5. Okay, then the input 1 gave us the output 7. The input 6, again, right? We plugged in a 6 here and we got out a 5. And we plugged in a 6 over here and we did not get out a 5. We got out a negative 5. So that means that the machine's broken. That's like plugging in some dough and getting out a tortilla, plugging in some dough, getting out a donut. That machine is broken. So it's asking which set of values is a function. This one is definitely not. Why not? Because the input 6, the x value of 6, gave us 2 different y values, 2 different outputs. Okay. So let's take a look at this one. Right here we plugged in a 6, plugged in a 7, plugged in an 8. And then look at this, guys. We plugged in a 7 again. Right here we plugged in a 7. Right here we plugged in a 7. But the first time we got out a negative 3. The second time we got out something totally different. So that machine's broken as well. And let's move on to the next one over here. We plugged in a 2, plugged in a 4, plugged in a 7, plugged in a 2 again. Do we get out a 4 again? No, we get out a 7 this time. So that one's broken also. Wow, this is not looking good, guys. So how about this last one here? We plugged in a 2, plugged in a 3, plugged in a 6, plugged in a 5. That's looking good. See, the fact is this, guys, we never plugged in the same input 2 times and got out different outputs. Now, some of us are thinking, wait a minute, but your output's the same. It's 3, 3, 3, 3. That's like the machine must be broken. No, it's not. That's like you plugging in dough and always getting out a tortilla. You get out a tortilla, you get out a tortilla. It's the same tortilla, right? As a matter of fact, let me explain. This is the actual function y equals 0x plus 3. So you see, whatever number you plug into x, when you multiply it by 0, it's going to become 0. And if you add 3, your output will be 3. So this is definitely a function. This is the only function, all right? So this is the correct answer for number 2. And again, on these type of questions, just remember, as long as you don't plug in the same input and get out different outputs, then you're good, okay? Let's move on to number 3. It says simplify. So what is simplify? It's PEMDAS, it's distributed property, combining like terms, and that's exactly what we're going to be doing right here. We're going to distribute and combine like terms. So whatever number's on the outside of the parentheses, distribute it in. 4 times 7x is 28x. 4 times, I want to call this a negative 2. That is a negative 8, but of course I put it as a minus 8. And then we're going to distribute the minus 6 times 1, that's a minus 6. And then minus 6 times positive 5x, that's a negative 30x. And of course, when we combine the 28x with the negative 30x, we end up with a negative 2 x. And then when we combine the negative 8 with the negative 6, we're going to end up with a negative 14. And there is your final answer, negative 2x minus 14. And as you can see, that's the answer that they give right here. Answer. Boom. Negative 2x minus 14. Question number 4. Solve. Okay, so we need to solve. What do we do to solve? You first have to simplify your equation. Make it a simple equation. Then after that, get x by itself on one side. And how do you get rid of things? By doing the opposite. So we need to simplify first. What does simplify mean? It means a distributive property or combining like terms. We're going to distribute negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Bring down the equals, bring down the 12. And then solve for x. Where's the x at? Well, here's the equal sign. The x is on the left side of the equal sign. So let's get this x by itself. Let's get rid of this minus 6 and then get rid of this multiplication of negative 3. So how do you get rid of something? By doing the opposite. How do you get rid of a minus 6? By doing the opposite, plus 6. What you do to one side, do to the other side. Let's rewrite what we have. The equal sign is going to come down. 12 plus 6 is 18. And the negative 3x, I'm just going to rewrite it down here, negative 3x, which really means negative 3 times x. Let's get rid of that negative 3 times in front of the x by dividing by negative 3. Again, the opposite of multiplication is division. That's why we're dividing by that exact value. That way the negative 3 will cancel with the negative 3, giving us a final answer of x equals negative 6. I hope everybody got that. If you want to double check your answer, you could take the negative 6 and plug it in. Negative 6 plus 2 is negative 4, and negative 3 times negative 4 is positive 12. So you could always plug in to double check and see if you got the right answer. Moving on to question 5. What is the first step to solving this equation? So if I tell you, hey, solve, what are you going to do? Well, the first step is to add 12. Add 12. And, I mean, do we need to solve it? No, it's just asking what's the first step? And there's the answer. Add 12 to both sides. Woo, easy. Number 6. We need to solve, and right here we do have a multi-step equation with variables on both sides. And of course, step 1 to solving any equation is to distribute, or actually simplify, which means distributive property or combining like terms, or both. I'm going to distribute first. Negative 2 times 3x is negative 6x. Negative 2 times positive 3 is negative 6. I want to bring down the equal sign, then distribute the 4. 4 times x is 4x, and then 4 times negative 9 is negative 36. So now I have an equation with no parentheses. We've already distributed. In other words, this is a simplified equation. All I need to do now is get x by itself on one side of the equal sign. So you ask yourself, where's the x at? Is it on the left side or is it on the right side of the equal sign? And the answer is it's on both sides, and you don't want it on both sides. So let's get rid of one of them. I want to get rid of the 4x by subtracting 4x. And what I do to one side, I do to the other side. Negative 6, take away 4x, that is negative 10x. Bring down the minus 6, bring down the equals, bring down that negative 36, and you have a more simple equation with x on the left side. And now all you have to do is get this x by itself on the left side of the equal sign. So I need to get rid of the minus 6 by doing the opposite. Plus 6 here, plus 6 over here. We end up with, let me rewrite it, negative 10x, bring down the equal sign. Negative 36 plus 6 is negative 30. What is this really saying? It's saying negative 10 times x equals negative 30. So I need to get rid of that multiplication of negative 10 by dividing by negative 10. And what I do to one side, I do to the other. My final answer will be x equals positive 3. And that's the answer that they have right there. X equals positive 3. Moving on. Number 7. Yes, it gets more fun. We are solving equations, and some of us freak out because of the fractions, but remember this, guys, you could get rid of any fraction you want by multiplying everything by the denominator of that fraction. So if you wanted to, you could get rid of the 2/3 by multiplying everything by 3. You could get rid of the 1/2 by multiplying everything by 2. Or you could get rid of both fractions at the same time if you multiply everything by the common denominator, which would be 6. Okay, so I'm going to explain it by getting rid of one fraction at a time, so I don't. Actually, I'll get rid of it by multiplying everything by the GCF. So if I think of 3 and 6 and 2, 3 and 2, they could both be changed to 6, right? So what I'm going to do is multiply everything by 6. This by 6, this by 6, this by 6, and that by 6. So 6 divided by 3 is 2. So what do I have left? I have 2 times 2, which is 4. Okay, and then 6 times 2 is 12, but again we have a minus sign in front, so that's a negative 12 with an x, minus 12 with an x. Bring down the equal sign. 6 times x is 6x, and 6 up on top divided by 2 on the bottom is 3, so I really have 1 times 3, which is 3, and let's not forget about that minus sign that goes right there. So there's my new equation with no fractions, okay? So I hope we understand how to get rid of all fractions at the same time. All you got to do is look at the denominators, the 3 and the 2, and decide what's the LCD and multiply everything by that LCD. Or you could get rid of one fraction at a time, which will take a little bit longer, but it'll still get you to the correct answer. Anyways, let's continue solving here. We have x's on both sides of the equal sign. I don't want that. Let's get x by itself on one side. I'm going to subtract 6x, subtract 6x. So if I owe 12 and I owe 6, I will owe 18 of those x's. Now this 4 right here, I'm just going to bring it down. Okay, and what do I have left? The equal sign also comes down. The negative 3 comes down. So here's my new, easier looking, simpler equation with x on the left side of the equal sign. I need to get it by itself on the left side. I'm going to subtract 4, subtract 4. I will have negative 18x equaling negative 7. Now that's really saying a negative 18 times x equals negative 7. So I need to get rid of that multiplication of negative 18 by dividing by negative 18. What I do to one side, I do to the other side. I will have x equaling, you can't divide 7 by 18. You can't even reduce a fraction 7 by 18, but a negative divided by a negative is a positive. So the answer is x equals 7 over 18. And that is the multiple choice answer that we had right here, 7 over 18. So I hope that makes sense. Let's jump to the next question, number 8. Evaluate the following expression. What does that mean? Evaluate means to plug in the value that they give you and then simplify using PEMDAS, okay? So they give us what value? They give us that x is equal to negative 3. So wherever you see an x, you see there's an x right here and there's an x right there, you're going to plug in negative 3. So the key to doing this correctly is to rewrite the whole variable expression with parentheses instead of the x. So we have a negative 2. Let's put x, or parentheses instead of x with the square, minus 5, and let's put parentheses instead of the x, and then plus 4 at the very end. Okay, again, all I did was replace these x's with blue parentheses. Okay, that x and that x, replace them with blue parentheses. Now let's actually plug in this value of negative 3. Okay, so this negative 3, I'm going to plug it inside those blue parentheses right there and right there. After that, all I need to do is simplify using PEMDAS, right? The correct order of operations. Are we going to start with subtracting, with adding, with multiplying, with exponents, with parentheses? You're supposed to think p parentheses, but there's nothing to do inside the parentheses, okay? So then you move on to e exponents, and you do have exponents. We have negative 3 squared. What is negative 3 times negative 3? That is positive 9. I want to keep the parentheses there so I could remember that I need to multiply by negative 2. If for some reason I don't put the parentheses, I might make the mistake of thinking that that says negative 29, but it doesn't. It says negative 2 times 9. Let me bring down the rest. I have a negative 5 times negative 3 plus 4. So now let's multiply the negative 2 times 9 and also the, I want to call it a negative 5 times negative 3. Even though it's a minus 5, I want to call it a negative 5. So what is negative 2 times 9? That's negative 18. What's negative 5 times negative 3? That's positive 15. Bring down the plus 4. And now from left to right, just add and subtract. If you owe 18 and you have 15, you're still going to owe 3. You're still going to owe 3. But if you owe 3 and you have 4, you're going to have 1 left over. And that's the answer right there. The answer is 1. Let's move on to question 9. Very simple, straightforward question. Is this a function or a relation? We are using the vertical line test, all right? Anytime you draw a vertical line, so there's my vertical line. If you run this vertical line from left to right, and if your graph touches it at more than one spot, then that means that it's no longer a function machine. It's a broken machine that we call a relation. It's not a function, it's just a relation, okay? So if I had something like this, let's say here's my xy plane, and let's say I had something like that, that's totally fine. That's a function. That works, right? If I take my vertical line, it'll never touch that red graph at more than one point, okay? But over here, look, boom, it's touching at 2 points, okay? So, or even another one, if I went like this, and if I had something like that, like kind of like a S-shaped curve, right there, the vertical line test fails because, as you can see, it touches at 3 points. 1, 2, 3. So what does that mean? It's kind of like, remember I said for functions, for each input, there's exactly one output. Right here on this input of 0, you're getting the answer 1, -3, and +6, right? So that one input gave you 3 different outputs. So the bottom line is this: whenever you see a graph, do a vertical line, get your pencil and just run it left to right. Oh, it touches at more than one spot. It touches at 3 spots. Okay, so that fails a vertical line test. It's not a function, it's just a relation. This one, it only touches at one spot right there. If you move it, it only touches at one spot right there. If you move it, it only touches at one spot right there. So this passes the vertical line test. So you would say, yes, this is a function. We said this one, no, not a function. It's just a relation. You know what I'm saying. And then this one over here, the one they're actually asking, this one is a relation because it touches at 2 spots. So this is definitely a relation. Vertical line test, that's what we're doing. Moving on, number 10. 10's an equation, and it's actually a proportion, right? You have one fraction equal to another fraction. This is where we cross multiply, sas, right? So we have 7 times 5, let's write that out. 7 times 5 equals what? 9 times, now the thing is this, because we have more than one term up here, we have to put those in parentheses. That's the only way it's going to work. Because if you just write 9 times x minus 2, you're going to make the mistake of thinking that that says 9x minus 2, but in reality, you need these parentheses. You need the parentheses around that x minus 2. If you don't have the parentheses around the x minus 2, you will not distribute and the whole thing will be wrong. You need the parentheses to remind you that you need to distribute. 9 times x is 9x. 9 times -2 is -18. Bring down the equal. 7 times 5 is 35. So we still need to get x by itself. We're going to add 18. Add 18. We will end up with the equal sign coming down. The 9x over here. 35 plus 18, that's 40. That's 53, that's weird. Okay, so 53, and we still need to get rid of the 9. And the reason why I say it's weird is because you need to get rid of the multiplication of 9 in front of the x. You divide by 9, and you can't divide 53 divided by 9. That'd be nice if it was a 54 divided by 9, but it's not. It's a 53 divided by 9. So the 9's cancel, you end up with x equals, and you can't divide it, you can't reduce it. That must be your answer, 53 over 9. And if you look at your multiple choice answers down here, I guess it got cut off. But down here, you will see the answer 53 over 9. So I hope that makes sense. If you can't reduce it, you can't divide it, just leave it like a fraction, 53 over 9. Number 11, we have an inequality. How do we solve inequalities? The same way we solve equations. The only difference is that on your last step, if you multiply or divide by a negative, you have to flip that inequality symbol. So let's add 3x here, add 3x over here. We will end up with, let me write it down here, 5x is less than 25. Final step will be to get rid of that multiplication of 5 by dividing by 5. That'll cancel. We will end up with x being less than 5. X is less than 5. There's your answer. Moving on to the next question. This next question is kind of blurry on my screenshot here. I apologize. But it's saying, what inequality does the number line represent? So we have a number line. Let me just draw it so it'll be a little more clear to you. And we have a -4, a -3, a -2, -5. And there's an open dot at -4, open dot, and it's going this way. Okay, so what does that mean? To the left, when it goes to the left, that means less. Okay, when it goes to the right, that means greater. That's great. I said great instead of right to help you remember. What does it mean that it's an open dot, that it's not equal to, right? It's just less than, not less than or equal to. If you actually had a solid line, like this option has this says x is less than or equal to 4, that would mean that you'd have to have a solid dot instead of an open dot. Okay, so this is going to be, it's an open dot, so you cannot have a solid line underneath your inequality. And it is to the left, so it's less than -4. So x is less than -4 is the correct answer to that one right there. Again, tips on inequalities. If you have a solid line underneath it, it's going to be a solid dot. Okay, again, if you have a solid line underneath it, it's going to be a solid dot. If you don't have a solid line underneath it, it's going to be an open dot. Okay, keep that in mind. Moving on to question 13. Question 13, one of the easiest questions in the test. Are these two lines parallel, perpendicular, or neither? Again, what you need to know is that parallel means you have the same slope. And as for perpendicular, perpendicular means that you have opposite reciprocal slopes. And what does that really mean, opposite reciprocal slopes? That means that you change the sign and flip the fraction. So that's what it means, change sign and flip fraction. Okay, so we should also know that these equations, in order for you to see the m value, you either have to have it in point slope form or as we have it here in this case, slope intercept form. Y equals mx plus b. Okay, and we could clearly see that these guys have the m value of -1/3 and also the m value of 3. So if these were identical, if they were both -1/3 and -1/3, then they would be parallel. But they're not identical, so they're not parallel. Are they opposite reciprocal slopes? And the answer is yes. What does opposite reciprocal slope mean? That do you change the sign and flip the fraction? Well, here's a negative. Does it change the positive? Yes. And if you were to take the 1 over 3 and flip them, and it becomes 3 over 1, that would be positive 3 over 1, which is the same thing as positive 3. So yes, these guys are definitely perpendicular. Perpendicular. Nice and easy. Number 14, this one's a little bit more interesting. It says, write an equation of a line in point slope form that passes through the point and has a slope of -5. Okay, so let me write down the information. Has a slope of -5. The m equals -5. Okay, so that's very important. And we also know that it passes through this point, which is a x and a y value. That's very important. And we know that we need this in point slope form. So what is point slope form? We need to have that memorized. It's y minus y1 equals m parentheses x minus x1. Now notice that I left it blank like that because that's how you're supposed to write it whenever you apply point slope form. Your y1 value goes right here, your x1 value goes over here, and your m value goes in front of the parenthesis right there. So we do have the x, the y, which goes here and here, the x1, y1 if you want to call them, and then the m, which is -5. So let's just simply plug it in. Y minus y1 equals m parenthesis x minus x1. So the y1 value is 8, put that right there. The x1 value is -3, put that right there. The m value is -5, put that right there. And of course, the only thing you could do here is change the minus to plus, and this is your answer in point slope form. Y minus 8 equals -5 parenthesis x plus 3. So that is your point slope form equation, and as you could see, that's the answer right here. Okay, let's move on to question 15. They are asking us to graph, and this is in slope intercept form. It's really easy. This is the m and this is the b. How do we graph with slope intercept form? You always start with your b value. That tells you where it crosses the y-axis. It crosses at 1, 2, 3, 4. So we could all start by putting the dot right there, and I got that dot from this b value. Now after that, I need to look at my slope. The slope is the steepness. I know that my line's going to pass right through this dot, right through that y value, right, of 4, that y-intercept of 4. It might cross going up like that. It might cross kind of steep down going like this, or maybe really steep down going like that. How could I tell the steepness? The steepness is told with the slope, and the slope is a fraction. So if you don't see a fraction right here, make it a fraction, put it over 1, and that tells you that the steepness is that it goes down 2 over 1, down 2 over 1. So I'm going to go down 2 units and over 1 unit and put a dot right there. Okay, down 2 over 1, and I'm going to put a dot right there. So I just connect my dots and I'm done. Whoops, that came out. Let me see. I guess that's doable. That's good enough. And you could identify which one's the correct one right there, which would be this guy over here. Again, y equals mx plus b. Find the y-intercept of the equation. I hope we remember to find the y-intercept, you set x equal to 0. And of course, the same thing to find the x-intercept, you set y equal to 0. So right here, they want the y-intercept. Let's set x equal to 0, and x is right here. Let's put a 0 right there. That'll say -9 times 0 And then we have the plus 8y equals 16. Plus 8y equals 16. So you really have negative 9 times 0, which is 0. So you really have the equation 8y equals 16, which is really 8 times y equals 16. Let's divide by 8. Divide by 8, y equals 2. That's your y-intercept value. Now, notice that the answers are given in coordinate format. So if we're talking about an xy plane, and we're talking about where it crosses your y-axis, and we say that it crosses at 2, that is right here. It crosses right there. What is that coordinate? That's the coordinate 0 on the x, 2 on the y. Now that makes total sense because you actually set this x value to be 0, right? And you found out that the y value was 2, right? So the input 0 gave you the output, the y value 2. So 0, 2 is the correct answer to this problem. So I'm looking for 0, 2 as an answer option, but it's not here. And I did cut out the final option, which was none of these. So on your practice test, that multiple choice option of none of these are correct is the correct answer. Let's move on to number 17. Number 17, they're asking us to graph. I like to change everything to slope-intercept form. Add 2x, right? You want to get y by itself on one side of the equal sign. So what we have here is 3y equals 2x minus 6. All you do is rewrite this, but with the x first and then the minus 6 second. After that, you have 3 times y. So the way to get rid of a multiplication of 3 in front of the y is to divide by 3. Divide everything by 3. Giving you a final slope-intercept form equation, y equals 2 divided by 3, you can't do it, so just leave it like that with the x. And then you have the b value of minus 2, because 6 divided by 3 is 2, minus 2. So what does this mean, guys? That our line crosses the y-axis at negative 2, and from that point I go up 2 over 3. I'm going up 2 because it's positive. If it would be a negative fraction, I'd be going down 2. But it's positive 2/3, so you go up 2 over 3. So this one crosses at negative 2. It goes up 1, 2 over 1, 2, 3. So this is our correct option. I hope that makes sense. Let's move on to the next question. Number 18, select all true statements. The equation x equals 2 has an undefined slope. Well, you know what? Since we're dealing with x equals 2 and y equals 2, let's do a quick little mini lesson here. Any x equals a number will produce a vertical line at the x value of that number, right? X equals 2 means you go to the x-axis, you go to the number 2, you put a dot there, and it'll be a line going right through that dot, a vertical line. Okay, that is like the wall. It's so steep, it's undefined. Okay, now if you do, now that's x equals 2, but if you were to graph, let's say y equals 3, okay, then you would go to the y-axis, right? The y-axis, you'd go up to the value of 3, 1, 2, 3, and you'd put a dot right there. And that would be a totally flat line going left to right, like that. It's a horizontal line, it's totally flat. Is that steep? Heck no, it's the opposite of steep. It's totally flat like your floor, which means the slope is 0. So if you understand that right there, you will be able to answer these questions. The equation x equals 2 has an undefined slope. Well, we said this red one was x equals 2, and yeah, it's so steep, it's undefined. So this is a correct answer. It says select all true statements. The equation x equals 2 is a function. Well, this red line is the x equals 2 line. Will it pass the vertical line test? And the answer is no, right? Or you could think of it in terms of inputs and outputs with regards to coordinates, right? This coordinate right here is the coordinate 2, 0. This coordinate right here is the coordinate 2, negative 1. This coordinate up here is the coordinate 2, 2. And all of these are x and y values, input and output values. So what we're saying is you plug in a 2, you get out a 2. You plug in a 2, you get out a 0. What? That doesn't make sense. You plug in a 2, you get out a different answer, negative 1. That doesn't make sense. That machine is broken. That is no longer a function. It's just a relation. So right here, this statement is saying that the equation x equals 2 is a function. We said, no, that machine's broken. So you would cross that out. That's not a true statement. The equation y equals 2 will never cross the x-axis. Well, we graphed y equals 3, we know it runs left to right. We know it never crosses the x-axis. So the same thing, y equals 2 would just be right here instead of up there on the blue line. Yes, it will never cross the y-axis, so that's another true statement right there. The equation y equals 2 has a slope 0. Well, if you were to draw y equals 2, let me do a quick sketch. Here's y-axis, there's 2, and it's totally flat. And yeah, that's the slope 0 because it's not steep at all, totally flat. The slope is 0. That's a correct answer. The equation y equals 3 has the y-intercept of 3. How do you graph y equals 3? You go to the y-axis, you go to the value of 3, 1, 2, 3, and you draw a flat line. Okay, now does that have a y-intercept of 3? Yes, it does. So that would be an answer. Also, this red line does cross the y-axis at 3. So those are all the true statements, all of them except that one. Let's move on to question 19. Which best represents the following inequality? This is already in slope-intercept form. Y equals m, which is negative 1/3, x plus b, where b is 2. So it's really easy to graph inequalities. You graph them exactly the way as you would equations. The only difference is that before drawing your line, you have to decide if it's solid or dotted based on this solid line right here. And then after that, you have to shade in either your answers are above that dotted line or solid line or below that line. So let's graph. It crosses at 2. That's where we get the b value, crosses at 2. From that point, I'm going to be going down 1 over 3. So down 1 over 1, 2, 3, and put a dot right here. I know it's an ugly sketch. I wish I had a nice graph, but I don't. But anyways, there's my line. And I could continue to go down 1 over 3, and I could go in the opposite direction. But the bottom line is my line will be right here. So the question is, will it be a solid line or a dotted? It is solid because of that solid line underneath. I'm just going to do a solid line. That is really disgusting. I apologize, but it's just a sketch. You'll be able to identify your multiple choice answer. Now, on top of deciding whether it's solid or dotted, you need to shade in either below or above. So if you were to test a point like 0, 0, plug in 0 for x, 0 for y, it'll say 0 is less than 0 plus 2 is 2. Is 0 less than 2? The answer is yes. So 0, 0 does work. This is an answer. It is, which means all my answers are down here. Another way of doing it is if the shortcut way. If y is by itself, y is less than, where is less than on the y? Up here is greater than, down here is less than. So you will be shading everything that is below your red line. So there's your answer. Let's take a look. It looks like this is our correct answer right there. Let's do this next one. On this next one, it's a little more challenging because it says which inequality matches the graph. So you actually have to, I would change all of them to slope-intercept form, get y by itself on all these guys, and then see what graph it matches. So we have 2x, adding 2x, adding 2x. Let's get y equals mx plus b. So we have 5y is less than or equal to 2x plus 10. Let's divide everything by 5, divide by 5, divide by 5. We have, whoops, what happened there? That's weird. We have y, whoa, y is less than or equal to 2/5 x plus 2. So even before continuing to draw and dotted or solid and then shade, this one right here is telling me that it crosses the y-axis at 2. And this does not cross at 2, it crosses at 3. So I could just disregard that one already. Let's take a look at this one. Let's get the y by itself. So let's divide by 3, divide by 3, divide by 3. We will have y is greater than, 3 divided by 3 is 1, x. You could put a 1, or you could even put a 1 over 1 if you want, plus 9 divided by 3 is 3. This one crosses at 3, and it does go up 1 over 1. Let's see if that's the case. It does cross at 3, but it doesn't go up 1 over 1. So that one's definitely not it either, okay? How about this one? Let's see. Let's get the y by itself. Let's go plus 2x plus 2x. We will have y is less than 2x plus 3. So this one crosses at 3, and it says that the slope is 2, which means it goes up 2 over 1. Let's see if this actually crosses at 3. And as you can see, it does cross at 3. I'll even put a dot right there at 3. It crosses at 3. And you do go up 2 over 1. So all we need to really worry about, let me actually show you that it goes up 2 over, goes up 1, 2, and it goes over 1. So it really does go up 2 over 1. So this is the right y-intercept. This is the right slope of up 2 over 1. The only thing we need to worry about is that there is no solid line underneath the inequality because it's a dotted line, and that it's a less than symbol because it's shaded below. And if we take a look at that, it is a less than with no solid line, so this is the correct answer, ladies and gentlemen, right here. This is the correct answer. Let's move on to the next one. Number 21. A line is perpendicular. So this one could be confusing the way it's worded, but it's this simple, guys. Where it says a line is perpendicular to this line, what does perpendicular mean? It means opposite reciprocal slope. So what is this slope? It's -2. So what I'm going to do is the opposite. I'm going to change the sign to a +2, and I'm going to take that 2 over 1 and I'm going to flip it. So my slope, my perpendicular slope to this slope will be +1 over 2. Once again, you change the sign and then you flip the fraction. Change the sign, flip the fraction. So it becomes +1/2. And that is the correct answer option right here. I hope that makes sense. Let's take a look at this one right here. Solving. This is number 22. Solving, we're going to simplify first and then worry about getting x by itself on one side. -7 times x, -7x, -7 times 3 is -21. Bring down the inequality, bring down the -5x minus 13. So now that we simplified it, now let's get x by itself on one side. I'm going to add 5x to get rid of it, add 5x over here. And let me rewrite what I have. So when I do -7 plus 5, that's a -2x. Let me bring down the -21. Let me bring down the inequality, which is a less than symbol, and also the -13 left over on the right side of that inequality. So now I have x on the left side of this inequality. Let's get it by itself by adding 21. And what you do to one side, do to the other, add 21. Let's rewrite what we have. We have -2x is less than 8. And let's continue to solve, getting rid of the multiplication of -2 right in front by dividing by -2. Our final answer will be x is, because we divided by a negative, you have to flip the inequality symbol, and x is greater than -4. Once again, if you divide by a negative, see that negative, you're going to have to flip the inequality symbol. So your answer is x is greater than -4, which is this option right there. X is greater than -4. Let's jump to the next question. 23. It says, write the equation in point-slope form. So you first need to know what point-slope form is. Let me zoom in right here so I could write down point-slope form. Point-slope form is y minus y1 equals m parenthesis x minus x1. Okay, so what do you need for a point and a slope? Well, you need a slope, and you also need a point. So what do they give us? It says they give us 2 points. And they give us the points -4, -7, and 2 and 5. So they want us to use these 2 points, but we need a point and a slope. We don't need a point and a point. We need a point and a slope. So how do we find a slope when they give us 2 points? You use a slope formula. M equals y2 minus y1 over x2 minus x1. And when you apply the slope formula, please do the division and the subtractions first, and then plug in your x's and your y's. Where are you going to get your x's and your y's from? From up here. X, y, x, y. This is your first point. This is your second point. And it doesn't matter which one you call your first and or your second. But just label them and then plug them in. Y2 is 5, Y1 is -7, X2 is 2, X1 is -4. Of course, the minuses change to plus. So your slope, your M, will be 5 plus 7, which is 12, and 12 over 2 plus 4, which is 6. So our slope will be 2, okay? So we now have a slope, and we now have some points, and now we will be ready to write it in point slope form. That's all we need, a point and a slope. Now, the only slightly confusing part right here is that I labeled this guy x1, y1. So I would be plugging in my x1 of -4 right there and my y1 of -7 right there. But right here specifically tells us use the 0.25. So on the multiple choice answers, they're going to be using this point instead of that point when they plug in the x and the y. So they want us to use, okay, how about this? This is the safest thing to do. Rewrite your slope right here, m equals 2, and focus on this slope and this point to write it in point slope form. Okay. So what is point slope form? It's y minus y1 equals m parentheses x minus x1, and it's the safest thing to do to rewrite it with blank spots the way I just did right there. And then plug in your y value of 5 right here, your x value of 2 right there, and your m value of 2 right there. There's your point slope form equation using that 0.25 and finding out that slope. So the correct answer is, where is it at? It's this guy right here. Last question, number 24. Convert to slope-intercept form. Obviously, this is in point slope form. Y minus y1 equals m parentheses x minus x1. But they want it in slope-intercept form, which is y equals mx plus b. They want y equals mx plus b. In other words, they want y by itself. And right here, y is not by itself. And you don't see any parentheses over here, do you? Right here we see parentheses. We need to get rid of those parentheses. So to get rid of those parentheses, we're going to distribute -4 times x, it's -4x. -4 times 2 is -8. Bring down the equal sign, bring down the y, the minus the 3. Now let's get that y by itself by adding 3 and adding 3. Of course, you will have y equals -4x, and -8 plus 3 is -5. There's your answer to question number 24.